Hello everyone, my name is Dionisius Rafael Makawaehe, and in this video I would like to explain about Gibbs space rule.
Okay, first of all, before we go for, we have to know what is Gibbs space rule. Basically, the Gibbs space rule, which is P plus N equals to C plus 1, gives the relationship between the number of phases P and component C in a given alloy under equilibrium conditions at constant pressure, where N is the number of thermodynamic degrees of freedom in the system. So we can say that the Gibbs space rule identifies the degree of freedom of a multiphase system that is in thermodynamic equilibrium. It relates the number of intensive independent thermodynamic properties for each phase and the number of phases for a system. Okay, at first we have known that formula for Gibbs space rule is P plus N equals to C plus 1. But for a system that does not experience a chemical reaction, the Gibbs space rule reads as P plus F equals to N plus 2. This P plus F equals to N plus 2 formula, where P is the number of phases present and N is the number of components present, the degrees of freedom, F designates the number of intensive independent properties that must be specified to fix the state of a system for each phase. Okay, next we have to know the application of Gibbs space rule. So, the application of the Gibbs space rule can be illustrated by considering the pure substance water, where N equals 1 when one phase is present, P equals 1, so that for the case of a subcolored solid, for example, it can be determined that F equals to 2. This means that two intensive properties must be specified to fix the exact state of the system. That is, the system can exist in equilibrium for any arbitrary combination of temperature and pressure. A system that must have two intensive properties specified is a system with 2 degrees of freedom. Another example for application of Gibbs space rule is pure substance that has 2 phases in equilibrium, such as saturated liquid and vapor. The number of phases in this case is P equals 2, and the number of components is N equals 1. Application of Gibbs space rule leads to F equals 1, which means that only one intensive property must be specified to determine the state of the system in each phase. If the pressure is given, the temperature is directly known, and therefore the state of the system in each phase is determined. However, the quality of the two-phase system, which is the fraction of vapor in the saturated two-phase mixture, is not known and is needed to find the relative amount of one phase with respect to the other. This type of substance has 1 degree of freedom. Now we're gonna talk about the exercise of the example problem of Gibbs space rule. So the problem is, how many independent thermodynamic variables are required to determine the thermodynamic state of the gas in canister of argon? Okay, before we go to the solution, you can pause this video and find the solution of this problem by yourself if you want to. So, the gas in the canister has only one component, argon atoms. Furthermore, as all these atoms are in gas, there is only one phase in the system. We thus have F equals to C minus P plus 2 equals 1 minus 1 plus 2 equals 2. It is necessary to give the values of two thermodynamic variables in order to state the thermodynamic state of the argon gas. Consider now the equation of state for ideal gas is P times V equals to N times R times T. If you are given the temperature and the volume, you can determine the pressure of the gas using this expression. Similarly, if you are given the pressure and the volume of the gas, you can determine its temperature. In other words, once you are given the values of two thermodynamic variables, you have fully characterized the gas's thermodynamic state. The equation of state for an ideal gas is thus consistent with Gibbs space rule. That's all from me, and hope this video will help you to understand about Gibbs space rule. And thank you for watching.